Today what we're doing is section 1.6, and the goal is I can determine the equation of a quadratic function given its roots. So this time you already know how to get its roots, or it's been given to you and now you can write an equation. So writing equations, not that difficult. Just like equations of lines, if you're given enough information, you can determine the equation of the line. Okay, and you did this in grade 9, y equals mx plus b. If they gave you b, if you could calculate the slope, then you could write the equation. Um, the same is true for quadratics. If I give you enough information, you can find it. So for instance, um, if I look at this, and this is y equals a bracket x minus r and x minus s, where r and s are the x-intercepts of the quadratic function, I can actually calculate the quadratic equation function for a specific quadratic. Now, this is a quadratic because if I do actually do FOIL, I'm going to end up with x squared, right? You can see that we're going to end up with x squared when I do x times x. So I know it's a quadratic. It will create a quadratic function equation. Now, the thing is, what is a little bit different is family of parabolas. Now, there are lots of different types of families of parabolas, but the one that we're interested in is all the parabolas that have the same roots. For instance, there are an infinite number of parabolas with roots 2 and 6. So you can see, for instance, I have two of them here, and you can see that both of these have roots 2 and 6. Now that's just two of them. I could draw, as I said, infinite number of them. So I mean, I could draw another one as long as it goes through 2. My parabolas aren't very good. And 6. Okay, there's another parabola that it belongs to the same family that has roots 2 and 6. So you could draw a lot of them, and as long as their roots are 2 and 6, they belong to the same family. The difference between these has to do with the A. Okay, obviously the red one has a positive A value. The the green and blue ones, both of them, the A is going to be negative because they're both turning down. So these all have a family with roots 2 and 6, but their A values are different. Okay, so their A values are different with a family of parabolas based on the roots. So they're different. And sorry, I'm writing with my mouse and it's kind of sloppy. So the A's are different. So let's take a look at calculating, first of all, a family of parabolas that have roots 2 and negative 6. And you're going to be just totally amazed at how easy this really is. So this time I'm going to bring up my pen. And so my family is based on y equals a x minus r and x minus s. And the r and the s are, in fact, these roots. So all I'm going to do is y equals a bracket x minus 2. And when I put the negative 10 in, it's going to be x plus 10. So it's that simple, okay, which really isn't that hard. So obviously it's not going to keep quite that simple. So let's take a look at the next type of questions that we're expected to do. This time, I'm just going to bring this up to that. There we go. Find the equation of the quadratic function that has roots positive 1 and 5, and it goes through the points negative 2, 10. So this time what's happening, it's not just a family, because the family would be y equals a x minus 1, if I put my roots in, and x minus 5. But this time I have another piece of information. I have a point that this parabola goes into. Now, by substituting this point into this equation, I will find not a family of parabolas, I will find a very specific parabola. So what we're going to do with this negative 2 and 6 is, this obviously is our x coordinate, and this is our y coordinate. So what we're going to do is we're going to substitute wherever there's x's, the -2, and wherever there's a y, we're going to substitute in the 10. So we end up having 10 equals, and I've got to stop writing with my mouse and start writing with my pen. I don't know what A is, and actually A is what I'm going to be finding. My x -2 minus 1 and -2 minus 5. So now you can see all I have is one unknown. So I can actually do the arithmetic that's on the right-hand side. So we have a -3 times a -7. And we know that's 21. So we have 10 equals A times positive 21. And again, remember I'm solving for A, so I'm going to divide both sides by the 21. So I end up with 10 over 21. Now that is in lowest terms, and I leave it as a fraction. Now, the question asks find the equation. So I have all the pieces of information that I need. Now, I'm not going to worry about expanding it after I substitute my information in. So I have y equals, and I'm using this form here, the blue form. So I have 10 over 21, x minus 1, and x minus 5. So this is not a family. This is a very specific parabola. I know that it opens up because 10 over 21 is positive. I know also that this number is less than 1, the A is, so I know that it's going to be a flattened parabola, and it has roots at 1 and 5. So that's not too bad. Then what happens is when they give you information that's a little bit more complicated. It's not any harder though. So it says find the equation of the quadratic function that has the roots 1 plus square root 2 and 1 minus square root 2. So this time the roots that I have here are simplified, okay, exact roots, okay, because square root 2 isn't perfect. So therefore, I'm going to leave it at this. And I also have that it passes through the point 10, -4. So just like the previous example, I start with substituting my roots in. So I have y equals a bracket x. Now, we just need to watch out because we have some negative stuff going on here. If I substitute my root in, my first one, 1 plus square root 2. And I also have x minus 1 minus square root 2. Now the reason we have those brackets on is because we're going to have some negative stuff going on. So y equals a, and we'll simplify this. We have x minus 1, and this negative is going to make this a negative root 2. And then on the other bracket, we're going to have x minus 1. Ooh, come on over here. Minus 1 plus square root 2. Okay, so just watch out for that. Now you're saying, oh, that's a real messy thing. It is in a sense, but it's not too bad. So what we're going to do now is we're going to substitute in. So I'm going to sub in 10, -4. And I probably should have told the person when I was doing the solution above that that's what I was doing at this point here, that I was substituting in the point. Okay, so this one should have better mathematical forms, which means the teacher would give me more marks. Okay, so this is my x and my y. So I have -4 equals a, and remember a is what we're trying to find. My x is 10 minus 1 minus square root 2, and 10, oops, come back here. Yes, I talk to myself. I even answer myself, by the way, which could be an issue. Okay, so this one is, get back over here, 10 minus 1 plus square root 2. And we have to keep those square root 2's. I can't change them to decimals. So again, it's just a matter of reducing this. So I have 10 minus 1, so I have 9 minus square root 2. For some reason, my pen just doesn't want to go where I want to put it. And again, I have 10, sorry, minus 1, which is 9, plus square root 2. Now what I have to do here is, remember, I'm solving for a, so I'm going to have to distribute this. Now you should recognize both of these brackets are identical. One's positive, one's negative, so that is really a difference of squares. So I'm going to do the shortcut for that because I know it's going to be the first number squared, which is 81. Take away the second number squared, which would be 2 squared, square root of 2 squared, which is 2. Okay, so there is no middle term because they would be canceled out because it's a difference of squares. So I end up with negative 4a, and I end up with a 79. And just like the previous example, I'm going to divide to find a, so I end up with negative 4 over 79. Okay, I wouldn't want to necessarily graph this one because that would be a little bit difficult to do. Just going to bring this up a bit for us. So I'm almost finished. I have my a, I have my roots. It's kind of a messy thing, but at least the root part is. So now let's go and bring our pen again. And we're going to put a therefore statement and put our solution down as soon as the pen goes where I want it to. So we have therefore y equals negative 4/79. And again, I'm going to use from up above, our first line where we actually substituted our roots in. And come back down here, pen, not down that far. As you can see that it's not perfect. So I end up with x minus 1 minus square root 2 and x minus 1 plus square root 2. Okay, so that is in root form, and that's the way I can leave it. Okay, so what you're going to do is tomorrow in class, you're going to actually do some questions.